We're here at Durham University today to talk about the Greenland Ice Sheet, and specifically what is hidden underneath the ice. I'm Dr. Bethan Davies from Newcastle University, and I'm joined by Dr. Guy Paxman from Durham University.
The Greenland Ice Sheet is a huge mass of ice situated on the island of Greenland. And in places, this ice sheet is more than 3 kilometres thick. There's more than 2,000 trillion tonnes of ice. And if all of that ice were to disappear, sea levels around the world would rise by around 7.5 metres. An ice sheet has existed in Greenland for at least 3 million years. Today, the ice sheet is melting.
The melting of the ice sheet is critical because more fresh water in the ocean not only raises global sea levels but also changes ocean circulation and alters the biochemistry of the marine environment. The topography underneath the ice directly influences ice flow and ice loss around the Greenland ice sheet.
In Greenland, ice flows to the sea through a complex network of hundreds of ice streams and glaciers. Glaciers that flow through low coastal valleys are particularly vulnerable to the warming of the ocean and may be more easily destabilised in the future. By contrast, other parts of the ice sheet are more resilient to ocean and atmosphere warming because they are hemmed in by these large mountains which act as barriers and help to stabilise the ice sheet.
Greenland is the world's largest island, and as you can see, 80% of it is covered by ice. The land that is underneath the ice has remained mysterious for a long time. Even today, we have mapped more of the surface of Mars and even Pluto than we have of the land underneath the Greenland ice sheet.
Since the 1990s, we've been progressively mapping the land surface that's beneath the Greenland ice sheet. We do this using radar systems which are mounted on aircraft which fly across the ice sheet and survey it. These radars send out electromagnetic waves which pass down through the entire ice sheet and bounce back off the land surface at the bottom. By measuring the time it takes for these waves to go down through the ice and return back to the aircraft, we can calculate how thick the ice is. And therefore, we can also work out how high the land surface is at the bottom. As a result, we get these amazing images of the landscape at the bottom of the ice sheet, just like an X-ray.
Let's look at an up-to-date map of the Greenland ice sheet. You can see from here that the lighter green and yellowy colours are the higher topography, and the dark green and blue colours are the lower topography. Greenland is ringed by these mountains that rise to up to 3,000 metres high. In the middle of Greenland, the land is much lower and flatter, and in fact, where it's blue, this part of the landscape is below sea level. Greenland is like a big bowl.
The reason that this land is so low is because of the ice sheet itself. There's such a large mass of ice sitting on the top of Greenland that it pushes the Earth's crust down into the mantle below. We call this process isostasy. If the ice sheet were to be completely removed, the land surface would actually slowly rebound by as much as 800 metres. This very same process has actually been happening in Scotland since the ice melted at the end of the last ice age around 10,000 years ago. The subglacial landscape is also a window into Greenland's deep past. If we are to look at the landscape beneath the ice, we can see great networks of valleys which cannot have been incised by ice, but were instead formed by running water at a time when rivers existed in Greenland. These features were probably formed at a time when the ice sheet was much smaller than it is today, and rivers flowed across parts of the Greenland landscape.
These features have survived for so long because large parts of the ice sheet are so cold and slow moving that there is very little erosion underneath the ice. The ice sheet is protecting the landscape below, and this landscape is literally frozen in time.
Researchers have also found sediments beneath the ice sheet, which we can tell cannot have been covered by ice as recently as 400,000 years ago. They tell us that there have been times in the past when the Greenland ice sheet must have been smaller than it is today. They provide us with vital clues as to what Greenland might have looked like at times in the past when Earth's climate was naturally warmer.
This information is so valuable because it will help us understand how the Greenland ice sheet will respond to climate change in the 21st century and beyond.
In summary, the subglacial topography beneath the Greenland ice sheet is really important. The valleys, mountains and basins beneath the ice all influence how the ice is flowing and melting today.
These data are vital if we are to understand and predict how the Greenland ice sheet will evolve in the next 100 years as the Earth's climate changes.